We have been working with the assumption that we actually know the population standard deviation, which is not always the case. Although the general idea for determining confidence intervals is the same, we will be using a different table than the Z table. The table of values we will be using when we do not know the population standard deviation is the table associated to the t distribution. Let us not be alarmed, because the t distribution is in many ways very similar to the standard normal distribution. For example, it is also symmetrical. But there are some major differences. The t distribution is very much affected by the sample size. See here, for example, the white curve would be the normal standard curve. This one would be the t curve for n of 6, and this one would be the t for n of 21. The z curve doesn't vary at all, no matter the size of the sample. So how do we know which curve to use? We must find what are called degrees of freedom. These are the number of values that are free to vary after a sample statistic has been computed. The degree of freedom for the t-curve is related to the calculation of the mean. So say you have a mean of 10 and you know your sample size is of 5. As such, the sum of your values must be of 50, because 50 divided by your n of 5 gives you a mean of 10. There are no restrictions for the first value in your sample. They could really be any value at all. So let us use 20 for the sake of example. For the second value, there is still no restriction whatsoever. Our second value could be 0, could be minus 15, could be 100,000 if we wanted to. But let's just say it's 5. Again, no restriction for the third, so let us say 9. Notice that up to now, our total or sum of our values is of 34. So we still have a lot of leeway before having to get to 50. For a fourth, we still have no restriction. This could be just about any value once again, so we will use 12. But the story changes for the fifth value. As we know, the total must be of 50. So the only value that can fit here is 4. So to calculate a degree of freedom for a t-curve, remember that degrees of freedom is the number of values that are free to vary after a sample statistic has been computed. All we have to do for the t-curve is simply do n minus 1. So here is the equation for calculating confidence intervals when the standard deviation for a population is unknown. It's very similar to the one we were discussing beforehand. We indeed have the population mean, the standard error, although instead of using the population standard deviation, we use the sample standard deviation, and instead of z, we have t sub alpha over 2. And just like when we were using the Z table, we can also calculate the confidence interval from a sample mean with exactly the same equation. Let's take a look at the T table. Now, unlike the Z table, the values that you have in the middle are not areas. These are actually the associated values of T. But just like the Z table, each value is associated to a specific row and a specific column. The left-hand column indicates the degrees of freedom for your distribution. Remember, that's simply n minus 1. On the top row, we have different situations, also illustrated in the figures on the complete top. We have one-tailed, two-tailed, but of more interest for us at the current moment is the confidence interval. So if we have a distribution with a degree of freedom of 13 and we are looking for the 98% confidence interval, the associated t value on both sides of 0 is minus 2.650 and positive 2.650. Now it's your turn. Pause the video and find t for a distribution with an n of 25 and a confidence interval of 80%. Now, because we have an n of 25, our degree of freedom is 25 minus 1, 24, and we're looking for the 80% confidence level. So we have t is equal to positive or negative 1.318. Well, actually, there are not one, but two situations where we must use the t-score table and not the z-score table. Here's a flowchart to help you take the correct decision. First, you must ask yourself, do I know the population standard deviation? If the answer is no, then you must use the t-score. If the answer is yes, then you have another question to ask yourself. Is my sample size smaller than 30? If the answer is no, then you may use the z-score. If the answer is yes, then you must use the t-score.